Hi, this is lesson number 12 on probability from actuarial path, and in this lesson we studied the variance of random variables. In our last lesson we studied the mean or the center of a random variable. Now, variance is a measure of the spread and the values taken by the random variable. Before I give you a formal definition of what a variance is, I'm going to show you some pictures to explain what variance means. I'm going to use this software R as I'm going to plot the PDF of a random variable which has mean 0. Okay, so you can see now this is a PDF of a random variable with mean 0 and the variance is 1. What happens if I plot a random variable with the same mean but a different variance? How different does it look? So I have now plotted a PDF of a random variable with mean 0 but variance of 4. So the blue has a higher variance than the red PDF. What this tells you is the variance is a measure of spread. So the higher the variance, the more spread out the values of the random variable are. Okay, with that, I'm gonna give you the formal definition of what a variance is. If we have a random variable x, so we have random variable x, which could be discrete or continuous, then the variance of that random variable is the expectation of the squared deviation from the mean. So where mu is the expected value of x, or the center, or the mean. Alright, that's the definition of variance of a random variable. Now this definition is not very easy to compute sometimes. So there is an easier formula, and I'm going to derive that. So the variance of x also can be written as the expectation of, let's square what's inside here. So when you do that, you get x squared minus 2 times mu times x plus mu squared. And that is equal to the expectation of x squared. You can distribute the expectation minus the expectation of 2 mu x plus the expectation of mu squared. Okay, so we have the expectation of x squared minus. Now, 2 times mu are constants because I'm taking the expectation with respect to x. So this is 2 mu, which can be taken outside of the expectation, times the expectation of x, plus mu square is again constant. The expectation of a constant is the constant value itself. So I have mu squared. And that is equal to, what do I know about the expectation of x? The expectation of x is mu. So we have the expectation of x squared minus 2 mu times mu plus mu squared. But 2 mu times mu is 2 mu squared. So this gives me the expectation of x squared minus 2 mu squared plus mu squared. Therefore, the variance of the random variable x can also be computed as the expectation of x squared minus mean mu squared. The Greek letter sigma squared is used to denote the variance of a random variable. So when you see sigma squared, that means it's a variance. So what we have now is the variance of a random variable is the expectation of x squared, which is the second moment, okay, minus the square of the first moment squared. Notice here that if I have a random variable x, let's say that random variable is time to finish 100 meters run. And that is measured in time units, let's say that's in seconds. But the variance is the square of x minus the average value squared. The unit of the variance, therefore, is square of the unit of the random variable. To make sure that the measure of spread has the same unit as the random variable itself, we introduce something we call the standard deviation of a random variable. So if we have a random variable x, the standard deviation denoted by sigma is the square root of the variance. In fact, you take the square root and take the positive value of the square root. So the standard deviation sigma is the positive square root of the variance. We're going to have two examples to look at, one discrete, one continuous. The examples are going to be in the next video lesson. Okay? Thank you for watching.